So this type, infinity minus infinity, we need to rearrange. So first of all, again, we're going to just check our limit. So we get 1 over log of 1 as it approaches 1 from the positive side. It's going to be 0 from the positive side, minus 1 over log 1, sorry, 1 minus 1 from the positive side is again 0 from the positive side. So we get infinity minus infinity. Okay, so this type is an indeterminate form, so we need to then apply L'Hopital's. So before we apply L'Hopital's, we need to first write it into a ratio form. And to write it into a ratio form, since it's fractions, we're going to get a common denominator, subtracting fractions. So we're going to get a common denominator, and we're going to subtract those fractions. So as x approaches 1 from the positive side, we're going to get a common denominator. So we get x minus 1 minus log x, and that's all over the common denominator of log x times x minus 1. Okay, so plugging this in now, checking this, we're going to end up with 1 minus log of 1, which is 0. Okay, so we get 0 over log of 1 is 0 times 0, so we get 0 over 0. There's our condition we need. Okay, and again, we need to make sure that we have established the right condition. Now we can apply L'Hopital's. So I'm going to apply L'Hopital's here. So to apply L'Hopital's, I'm going to differentiate the numerator and denominator separately. Okay, so we're going to end up with 1 minus 0 minus 1 over x. That's the numerator. The denominator is 1 over x times x minus 1 plus, and this just becomes log x when we differentiate the x part of that. So plugging this all in, I'm going to end up with 1 minus 1 over, and this ends up being 1 minus 1 over x, so 1. So we can, and actually maybe we can just do it this way. We can just do it as 0, 1 over x, 1 over 1 times 0 plus 0. So we end up with 0 over 0. Okay, so it looks like we got absolutely nowhere with this L'Hopital's. However, we actually did get somewhere. We can actually just reapply again because we've got the condition again. So I'm going to apply L'Hopital's again. Again, I need to make, as long as I have that condition, I can continue applying L'Hopital's. So I'm going to put brackets. This is my second time applying L'Hopital's. So I end up with limit as x approaches 1 from the positive side. That 1 differentiates to 0, so I get negative. This becomes positive 1 over x squared. Okay, this one here, I really should differentiate this. So I'm going to maybe simplify this. So this is going to be negative 1 over x over 1 minus 1 over x plus log x. So this becomes, in the denominator, I end up with 1 over x squared plus log x. The derivative of log x is 1 over x. Okay, so then I can put in my limit. So 1 on top, 1 plus 1 on bottom. So I end up with a limit. My limit is equal to 1/2. Okay, so the limit of that original expression is equal to 1/2.